So another fundamental aspect of Python is functions, which you can also refer to in math. So functions in Python are a block of organized, reusable code that performs a set of specific procedures or operations, which is very similar to how they are used in math. So we have some built-in Numpy functions, such as np.sum, which sums an array or list. So 1 plus 2 plus 3 is 6, and so np.sum of that array would be 6. We also have another built-in Numpy function like np.round, which will automatically round arrays, the end decimals of arrays. And in this case, it's specified to the second digit, so it will round each number to 2 decimal places. So 0.015 gets rounded to 0.02, 0.235 gets rounded to 0.24, and 0.112 gets rounded to 0.11. And similarly, we have np.countNonZero array, which counts basically all of the numbers that aren't zeros. So as we can see, the non-zeros in this case would be 1, 2, and 3, and so our return would be 3. And there are actually a ton of different built-in Numpy functions. These are just a selection. So I recommend you go look at the Numpy documentation to see all the different functions you could find and use. So what are functions, or what is the syntax of functions? So how we write functions is we first put def, which stands for definition, and then we put a function name. In this case, it would be spread, and then a brackets and the values we are taking, or the parameters we are taking in that bracket. So in this case, we'll just use values. We can also use a variable named x to refer to whatever's in that bracket, or whatever we're going to put into that function. So, and then in our body, we would put our code, or as we mentioned before, our set of instructions. And usually functions have a return signal. Doesn't always have to, but usually it has a return function so that once this is called, it does return something or output something. So in this case, it returns the maximum of the arguments put into values and the minimum of the arguments put into values. So, for example, if we were to put an array of, let's say, 1, 2, and 3 in our values, it would return the maximum of it, which is 3, minus the minimum, which is 1. So 3 minus 1 is 2. So if we called spread on that value, it would equal 2. And so some key things to look out for is a function name, which we can define. And as we mentioned with variables, it should be pretty descriptive. Argument names, which also should be pretty descriptive, as well as a return expression, and our body of code or instructions. And this is what a function typically looks like and the syntax that is involved. So one example of another function is def f of s, and then you can see there's a colon, which is really essential as well. Return np.round s divided by np.sum times 100, and then 2, or so rounded to the second decimal, or to 2 decimal places. So in this case, we can see in our hashtag s is an array, or a comment, that what will be inputted into this f function is an array. So if we call f 1, 2, 3, we will get 16.67 since it's rounded to the second digit, 33.33, which is rounded to the second digit, and 50. And unlike floor divides, we can see here that it just follows regular rounding. So if you're above 0.5 or at 0.5, it will round up. And then if you are below, it will round down or keep the same. So yeah. As we can see, our 50 ended up not having decimal places, so it just was 50. It just is 50. So yeah, and we can follow the process as well through these individual steps, which are shown below. So first we sum it, 1, 2, and 3, which is 6, like I mentioned before, and then we round it. We round s divided by the sum. So it would be 1 divided by s or 1 divided by 6, 2 divided by 6, and 3 divided by 6, and then multiply that all by 100. As we can see inside that np.round built-in function. And then once we get that, it's rounded to the second. And so you can see this is how we got our number. So another key part of Python is conditionals. So conditionals are basically if-else functions, or colloquially speaking, if something happens, else. If something happens, then something will happen, and if it doesn't, then something else will happen. So this structure is commonly used just in speaking. So for example, if I want a pizza, then I'll go get a pizza. But else, see, I don't want a pizza, I will get another food. So this is a pretty intuitive structure, and in Python, it's a really essential structure. So we use the if condition 1, you can see the structure on the left. If condition 1 is true, then they will do the code of function that is true. So it's similar to functions in that it will complete a certain number of steps if something is true, or if you call it. So it will call a function if something is true. And elif is another word for else if. So if the first condition is not true, then it will test whether the second condition is true. So for example, say in my previous example, if I want pizza, if I want pizza is not true, then our condition 2 can be I want sushi. And if sushi is true, then it will do condition 2, or whatever it will specify. For example, in this case, it could be I will go get sushi. And finally, we can talk about else, which is if condition 1 and condition 2 is not true, then we'll do some other various code. So in this hypothetical example, so if I am not in the mood for sushi and I'm not in the mood for pizza, I will get some other food. So it's important to know that even though if elif and else is in this structure, in this example, you actually don't always need an elif or else. Sometimes people just use if and else. Sometimes people just do if with no else. And sometimes there can be more than one elif. The key piece of information here is that there is always an if condition and then a set of instructions. That is always necessary in these conditionals. And it's important to note also that the conditions in these conditional statements must be Boolean, so true or false. So if I am hungry is true, either true or false. And so here's another example of a function where conditionals are used. So as you can see, our function is called onebet, and it takes in some random variable x. So if x is less than 2, then we'll return -1. Or if it's not less than or equal to 2, if x is less than or equal to 4, then return 0. Else, if x is less than or equal to 6, then it will return 1. And if these are all not true and x is just greater than 6, then it will print my die only has 6 faces. So we can test how that number will be applied in multiple cases. If you see on the right, if it's 5 that is plugged in, then it is less than or equal to 6, so we'll return 1. If it's 10, it's greater than 6, so we'll return 6 faces. And if it's 1, it will return, since 1 is less than or equal to 2, it will return -1. So this is one small example of how conditionals can be used in a function.